A6 of the OWASP Top 10 is Security Misconfiguration. It applies to default configurations, unpatched applications, out-of-date software, ad hoc configurations, open cloud storage, misconfigured HTTP headers, and verbose error messages containing sensitive information. Let's take a look at bbox. Down to Security Misconfiguration. And I see here Insecure FTP Configuration. We've already demonstrated that in a previous lab to show insecure file transfer. Let's revisit that really fast. Going to FTP to the bbox. Specify a username of anonymous and no password. Now the issue here is we're able to anonymously log into FTP. This destroys accountability and allows us to access the FTP server without using a password. Also, any of the documents in here, if they have sensitive data, anybody can download it and anybody can access the FTP server regardless of authorization. Now back to BWAP. I see here that there are two local privilege escalation vulnerabilities. Now, to exploit these vulnerabilities, we need some sort of access to the system. So remember the low privilege shell we were able to get with the PHP backdoor? Let's get that again and escalate our privileges to root. Just as a refresher, here's how we are able to get the low privilege shell. MSF console to start up Metasploit. Use exploit multi-handler. Set lhost, localhost is a Kali Linux box. Set lport 4446, that's the port that was specified in the payload that was generated. Set payload php / interpreter reverse TCP. Run. Now we're ready to leverage our remote file inclusion vulnerability. Here it is. We have a interpreter session opened. It's changed to a shell. Now let's run a Python one-liner to spawn a TTY shell, make it more interactive. Good. Now, there are two methods we can use to escalate privileges to root locally. This fits under the out-of-date software category of the A6 security misconfigurations portion of the OWASP Top 10. In a previous lab, we were able to leverage PHP to acquire a limited privilege shell. Now we're going to use that shell and escalate our privileges to root. See what directory I'm in. Just go back one directory. The exploits we need are in the evil directory. So I just changed directories to evil. Here's the first one we're going to use. So CVE-2009-1185.c leverages udev, launching an executable from the temp directory with root privileges. To give a little background of this underlying vulnerability, udev before version 1.4.1 does not verify whether a netlink message originates from kernel space. This allows a local user, such as our www user, to gain root privileges by sending a netlink message, which is what we're about to do. First, we need to generate a malicious payload and ship it over to bbox with wget. So let's open up a terminal here. Here's our MSF Venom command. So we're specifying a payload of Linux for a 32-bit architecture and a Meterpreter reverse TCP shell. We have a local host of the IP address of Kali Linux, a local port of 5000, file type of ELF, which is a Linux executable, and output, we're going to put it in var www HTML and name it run. Now this is very important to name it run because the exploit executable is going to look for a file named run in the temp folder. Good. Now let's start up Metasploit. We're going to start another exploit multi-handler. Use exploit multi-handler. Set lhost to the IP address of the Linux box. Set lport to the port we specified in the payload, which is 5000. Set payload. Set it to the same thing we set it to in the payload, the Linux Meterpreter reverse TCP shell. Run. It's good to go. Now let's download the run file from Kali Linux. I have a wget command here to connect to the Kali Linux box, download the file run, and output it to the temp directory under the name run. Now we're going to use gcc to compile the exploit. I'm going to output it to the temp directory under the name priv escalation. Change directories to the temp directory. See here we have our files run and priv escalation. Now I'm going to change modification plus X. I'm going to give priv escalation executable rights. Now, we need to know the process ID or PID of udev, and then subtract 1 from it to supply that information to the exploit executable. So let's run psaux, pipe that to grep, and search for the name udev. Good. So the PID is 2474. Minus 1 from that is 2473. That's the information we need to pass on to the exploit executable. Let's launch our executable and see if we can get our shell. So /priv escalation, and the PID -1 was 2473. Let's go back to our multi-handler. Good. We have a Meterpreter session opened. Let's open up a shell. And once again, use our Python code to get a interactive shell. ID, root. We have root privileges now, escalated privileges. Who am I? Root. Good. We've successfully escalated privileges. Now, if you have any problems with this, go back to the beginning and try again. There's a lot of steps in this, and it's easy to make a mistake. The other local privilege escalation is very easy. Let's just go to the var www evil folder. I have my low privilege shell here. And here is the other one, 2009-2692. It is tarred, so we have to untar that. Just run this tar command. Now all we have to do here is run this shell script. So it put it into a folder. We have to change to that folder. Here's the shell script here, CVE-2009-2692.sh. So just sh, and paste that name here. Got root, just like that. Very simple. Here's your proof. Good. Now that I've shown you the exploit in action, let me explain the vulnerability. CVE 2009-2692 is a vulnerability that applies to various Linux kernels that don't initialize all function pointers for socket operations in proto_ops structures. This allows local users, such as our www user, to trigger a null pointer dereference to gain privileges by using mmap to map page 0, placing arbitrary code on this page, and then invoking an unavailable operation. Essentially what we did is use a shell script to map 0 page, and it escalated our privileges to root right away with no issues. It was a lot easier. For more information, visit Common Vulnerability and Exposures.